In lesson 7-8, we're going to be looking at the value of a ratio. This is something that's going to continuously come up. We use it to help us solve ratio problems. And the value of a ratio is a ratio written as a fraction in simplest form. So this is what is super important here. The definition of a value of a ratio is a fraction in simplest form. So if it asks you for the value, it's expecting you're going to know to write it as a fraction in simplest form. Okay, so not using a colon, not leaving it as is without simplifying, fraction in simplest form. So the first example, the ratio given to us is for every 2 boys, there are 8 girls. The ratio of boys to girls is 2 to 8. This simplifies to 1 to 4. Okay, so notice they're writing everything with a colon so far. We haven't talked about value at this point, so you can write the ratio however you would like. However, the next piece says the value of the ratio is 1/4. Okay, so we now have a fraction in simplest form. So we just have to take the simplest form of the ratio and make sure it's written as a fraction. Because of the order of the fraction, we say the number of boys is 1/4 the number of girls. Okay, so whatever the value is, whichever order that's written in, it would be the first number is whatever fraction the second number. Okay, so the next piece is changing the order of the ratio. It says the ratio of girls to boys is 8 to 2. So they just flip the order of the ratio. Girls are first, boys are second. This simplifies to 4 to 1. So the value of the ratio is 4/1. This can be, and this is the only time we would really write a ratio as a single number, because remember, a ratio is a comparison of 2 numbers. But since we're looking at the value of this ratio, it's okay to simplify that to 4. If I wanted the ratio, I would need it to be 4 to 1. We say, in this case, the number of girls is 4 times the number of boys. Okay, so very similar to how we've written it before, but instead of writing it as a fraction of the number, because it's a whole number, we say it's 4 times the number of boys. And if you think about it, 8 is 4 times 2. Okay, so let's look at some other examples. Okay, so in example 1, it says for every 6 red chairs in the cafeteria, there are 4 blue chairs. So we've got our for every, there are ratio words. We know this is a ratio. What is the value? Again, this means fraction in simplest form of the ratio of red chairs to blue chairs. Okay, so I'm going to start by keeping it in fraction form so I know I'm in the right form when I get to my value. It's red to blue, so red over blue. The number of red chairs is 6. The number of blue chairs is 4. I've got my fraction. Now I just need to put it in simplest form. Both 6 and 4 can be divided by 2. So 6 divided by 2 is 3, 4 divided by 2 is 2. The value of this ratio is 3/2. Letter B. What is the value of the ratio of blue chairs to red chairs? So now I'm going to put blue over red. There are 4 blue chairs. There are 6 red chairs. Simplify, dividing both by 2. 2/3 is the value. Letter C, what is the value of the ratio of blue chairs to the total chairs? So now we're going to take the numbers in the ratio and add them together. We had 6 red. We had 4 blue. So that means we have 10 total chairs. So I'm going to put blue over total to follow the order of the ratio. Number of blue is 4, total is 10. I want to put this in simplest form. Divide both by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. The value of the ratio of blue chairs to total chairs is 2/5. What is the value of the ratio of total chairs to red chairs? So I'm going to do total over red. Total is 10 chairs. I'm using that from the previous. Red chairs is 6. I need to put this in simplest form. Divide both by 2, which gives me 5/3. So the total chairs is 5/3 the number of red chairs. Okay, example 2. Which of the following ratios have a value of 2/3? So in order to do this, what I'm going to do is I'm going to find the value of each of the ratios that are given to me and see which ones of them are equal to 2/3. I know that's hard to read. Okay, so I'm going to take 12 to 15. I'm going to turn it into the fraction 12/15. I'm going to put it in simplest form by dividing both by 3, which gives me 4/5. 4/5 is in simplest form. It's not equivalent to 2/3, so letter A would not have a value of 2/3. Letter B, turn it into a fraction. Put it in simplest form by dividing both numerator and denominator by 4, which gives me 2/3. This has a value of 2/3, which is what we're looking for, so letter B would be an answer choice. Looking at the next one, 16/24. I'm going to simplify by dividing both by 8. 16 divided by 8 is 2. 24 divided by 8 is 3. This has a value of 2/3, which is what we're looking for. So again, turn them into fractions, put them in simplest form. Letter D, I'm hoping most of us can look at this and say that it's not going to be equivalent because we have a larger number on top than we do on the bottom, and here we do not. But just for fun, we'll simplify it. I'm going to take a 0 for a 0. That means I'm dividing both numbers by 10. And now I can simplify by dividing both by 2 to get 5/3. So not 2/3. So B and C would be our answer here. Again, a value is a fraction in simplest form. Okay, example 3 says 1/6, I know that's hard to read, of the students in Mrs. Kitchell's class have blonde hair. If there are 24 students in Mrs. Kitchell's class, how many have blonde hair? So when it's saying 1/6 of the students in Mrs. Kitchell's class have blonde hair, what that means is 1 out of 6 have blonde hair. So 1 is blonde out of 6 total. I'm going to use equal fractions to help me with this, so I'm taking that value and I'm using it to create an equal fraction. In my equal fractions, if I have blonde in my numerator here, I have to have blonde across from it in my numerator here. If I have total in my denominator, I have to have total here. The extra information in this problem is telling me that there are 24 students in Mrs. Kitchell's class. So that would be a total number in the class. So next to total, or T for total, I'll put 24. Just as with equal fractions that you've learned in the past, whatever you do to the numerator, you must do to the denominator and vice versa. I'm going to see what I did to the 6 to turn it into 24. If you're not sure, you can take the 24 and divide it by 6, but hopefully we know that 6 times 4 gave us 24. So now I'm going to do 1 times 4, and that's going to tell me how many blonde students there were, which is 4. So I've used that value to help set up an equal fraction to find my answer. Okay, example 4. There are 250 students in 6th grade. 3/5 of the 6th graders are in band. What is the value of the number of students not in band to the number of students in the band? Okay, so I'm looking to find a value of the number of students not in band to the number of students in the band. Okay, I actually don't even need the 250 at this point. I can use it if I want to kind of get an actual number of students, but I can just use the value given to me. I'm given that 3/5 or 3 out of 5 of the students of the 6th graders are in band. So what that's saying is 3 out of 5 are in band. 3 are in band out of 5 total. Looking back to what I'm looking for in my value, I need to know the number in band, which that's given to me here as 3. I also need to know the number that are not in band. That's not given to me in this value. To find the number that are not in band, I would take the total number of students, I would subtract the number that are in band, and what's left over would be the number of students that are not in band. Okay, so now that I've done that, there are 2 not in band. This fraction here, the 2/3, is simplest form, so that's my value of not band to band.